Yes, students, last time our discussion was regarding importance of concepts of quality. Will you help me to share the importances? Let me start the screen sharing also so that whatever the responses you will give, those also will be recorded. Yes, now I am waiting for your answer in chat box. What is the first importance? Meeting customer expectations. Very good, very good. Alia, Swapnali, brilliant. What about others? They also should answer. Good, good. What is the second importance? Right, managing reputation in market. Yes, Swapnali, Alia, right. Third, only one has answered. Okay, Ali also. Okay, many, all you answered. Okay, meeting industry standards. Yes, right. The fourth importance. Right, Alia, Ganesh. Right, variability of materials. Fifth importance. Okay, good, Ganesh, Swapnali, Alia. Sorry, customer satisfaction. Right. Sixth importance. Yes, forecast liability. Seventh importance, right, reducing cost. Okay, in that customer satisfaction, have you told? Ah, yes, it was there. Yes, it is there. Yes, students, after this, a point in your syllabus is about the various standards we use in the industry. About those standards, I give the information first. Listen carefully. And in case if you have any doubt, you can ask. Before to start that, do you have any doubt about the previous studies? Right from concepts of quality to importance of the concepts. If no doubt, then you can say no. Are you answering? Oh, you are answering. No doubt. Now I come to the next point. The point is chemical standards. And various types of the standard materials are there, or reference materials are there. Different wordings are used there. In that, the first name is primary reference standard. Why for we are talking this standard? See, this quantitative estimation is related to the concentrations of various solutions. And concentration is related to quantity of that main solute. Maybe it is in terms of volume or it is maybe in terms of the weight. And that quantity we should take exactly to prepare exact solution, proper solution. But many times it is found the compound that we take is not fulfilling the actual norms of the weighing or volume measurement. It may not necessarily be pure. If it itself is not pure, then how can we weigh it exactly? It's a main concern. For that, we need to take such a material which can be weighed exactly, and from that material we have to standard the other material. So primarily we perform that one standardization. Primarily we perform the standard solution. And with the help of that standard solution, we standardize the other solution. Example I give it to you. If you see HCl solutions remain in the laboratory. But HCl solution exactly we cannot prepare, because how can we prepare the HCl solution, concentrate HCl solution, and after dilution we can prepare the actual dilute HCl solution, maybe the 0.1 normal or 0.01 normal. Such a dilute concentrated solution we prepare. And if we see the concentrated HCl solution, its concentration remains about 11.4 normal or molar. See, 11.4, from that we have to prepare zero point 0.1. For the sake of brevity, if we consider 10 molar, it is approximately, is the actual concentration of concentrated acid. From that we prepare the dilute acid. And dilute acid concentration remains how much? 0.1. Means it is almost 100 times less. I repeat, concentrated HCl, its concentration in true sense expected to be 11.4 normal, but for calculation point of view, I am considering 11 near to 10, no? So it is about 10 normal or 10 molar. But from that 10 molar or 10 normal solution, we have to prepare a desired chemical in our laboratory, and that solution remains only 0.1 normal or 0.1 molar. Students, I want answer from you that 0.1 normal or 0.1 molar solution is dilute compared to 10 molar. So compared to 10 molar, 0.1 molar is how many times dilute? Compared to 10, 0.1 is how many times less? Is my question clear? Okay, I repeat. concentrated HCl is approximately of 10 molar concentration. Actually, I said 11.4. But for calculation purpose, I am taking number 10. 10 molar is a concentrated solution. From that, I have to prepare 0.1 molar or 0.1 normal solution. So this 0.1 is how many times less than 10? How many times dilute than 10? Is question clear? So I am waiting for your answer and I am keep for recording your answers. I am keeping for on record. Is my question clear? If not, I'll repeat. The students, I am not getting your replies. If not clear, yes, say not clear. I'll repeat the question. Or if any other thing you have to say, unmute and talk or chat. Reply. I am waiting for your replies. Yes, one can unmute and talk also. What happened?
Repeat, sir.
Okay, I repeat. See, suppose if I am with the 10 molar solution. From that, if I have to prepare 5 molar solution, then I have to decrease the concentration or increase the concentration? Please answer. From 10 molar, I have to prepare 5 molar. So I have to decrease the concentration or I have to increase the concentration from 10 to 5. Decrease or increase?
Decrease.
Yes.
Decrease.
Yes, Ismail, right. I am waiting for others. Yes, there is a decrease. So to decrease the solution, what will you do? You will add water or you will remove water. Remove water means by evaporation. If you want to
By
decrease the
evaporation.
concentration of solution, you will dilute it to decrease the concentration or you will evaporate to remove the water in present in that.
Evaporate to remove the water present in the solution.
Okay, what about others? Aliyah saying dilute. Yes. What about others? Swapnal is saying dilute. Yes. If we add water, its concentration will decrease. Means if we take a 4 spoons of sugar in 1 cup or 1 glass, and a little water, half glass water, if you add water in that, it will be dilution, dilute solution. Concentration will decrease. If you evaporate, means you decrease the water, concentration will increase. So for dilution, we have to add water. I want to say to decrease the solution, to decrease the concentration of the solution, we should add water. Are you following what I am saying, Ismail?
Yes. Yes, sir.
Other students, are you following? Okay, good. So from 10 molar solution, listen carefully now. From 10 molar solution, I am preparing 5 molar solution. There is a decrease in concentration. So as per your suggestion, I have to dilute that solution. From 10, I have to bring it to 5. How many times I have to dilute that solution? 10 to 5. How many times? 2 times, 5 times, 10 times, 20 times, likewise. I should dilute that solution. Yes, Ali has given answer 5. Swapnal is saying 5. Ganesh saying 5. Mayur saying 5. And any other Yash saying 5. Okay, I think nearly all you want to say the 5. See, common sense is that how many times I said dilution in reverse way. So 10 is a one number and 5 is other number. So if you want to find number of times, then just ratio you have to take. If you say 5 and 10, half concentration. Half concentration means double dilution. Yes, Aliyah, now you are right. Double dilution. Means if you take 1 liter of that 10 molar solution, add 1 liter water, you will get 5 molar solution. If it is with 100 ml or 100 cubic centimeter, add 100 cubic centimeter water, you will get half concentrated solution. So how many times it is less, those many times we have to dilute. I repeat, how many times concentration decreases, those many times we have to dilute the solution. So here concentration is decreasing by 2 times, means 10 divided by 5 means 2 times decrease is there. Or concentration is half, decrease means reciprocal will be there, 1/2. So half concentration you are taking. So if it is there, those many times you have to dilute, means 2 number is there, 2 times you have to dilute. So to prepare, listen carefully, to prepare 5 molar solution from 10 molar solution, we need to dilute that 10 molar solution 2 times. Is it clear to all? Okay. Now listen question carefully. From 10 molar solution, I want to prepare 1 molar solution from 10 to 1. How many times I should dilute? Okay, Alia saying 10, Ismail saying 5. Other students, is logic not clear to you? 10 is a 1 concentration, other is a 1. You take ratio, high concentration to a low concentration. Whatever the ratio comes, that many times, those many times dilution. 10 divided by 5, 2 was coming. So those many times, 2 times dilution. Means 2 times you will add water. So my question, from 10 molar to 1 molar solution if you want to prepare, then Ismail, what is the ratio of 10 divided by 1? Yes, it's a 10. So dilution should be 10 times. Again, answer the question. From 10 molar solution, if I have to prepare 2 molar solution, from 10 to 2, how many times dilution? Yes, 5 times. Okay. Now I come to my original question. From 10 molar solution, I want to prepare 0.1 molar solution. From 10 to 0.1. 0.1 means 0.1. How many times should I dilute? Dilution how many times? To prepare 0.10 solution, dilution how many times? Yes, 100 times. See, means if you take 1 glass of that concentrated solution, 100 glass, up to that you have to dilute. If you take 1 cubic centimeter, 1 ml of that concentrated solution, up to 1 liter you have to dilute to prepare 0.1 molar solution. Means generally we use that 0.1 molar or 0.2 molar of that range. Concentrated solution is nearly 10 molar, and from that 10 molar we are preparing the solutions of 0.1 molar. So considerable dilution we are doing. That diluted solution can retain the uniformity in its concentration, can withstand at that concentration, can remain with that concentration. But if you see concentrated solution, means in laboratory you might have seen the concentrated reagents, the fumes or vapors do come. So HCl basically, which is the gas in nature at room temperature, it is passed through water, and saturated solution, concentrated solution is our concentrated acid. But that bottle, that concentrated HCl cannot, that HCl actually gas cannot remove out, gas can slowly go out, and because of that, during manufacturing, what was a concentration that may not be till it returns to laboratory, till it comes to laboratory. Or in laboratory, whatever the concentration before 1 month may not be now. Concentration yesterday before may not be now. So it is not a very standard thing by which we can prepare the concentration. So main solution, concentrated solution, its concentration itself is not known for us. Exactly I am talking about. So exact concentration of dilute solution we cannot understand. So that HCl cannot be the standard. HCl cannot be the primary standard. Similarly, yes, are you getting this point what I am saying about HCl? Similarly, if you see NaOH, sodium hydroxide, can anybody answer in laboratory? Sodium hydroxide basically remains in which form? Solid form or liquid or solution form?
Liquid.
Okay, Ismail saying liquid, Rupashri saying liquid. Okay, that you are using liquid form, but that liquid means solution is prepared from solid. Means if anybody has given a sugar solution, and said it is sugar solution, from that don't say sugar is liquid, sugar is a solid at room temperature. Salt solution, don't say salt is a liquid, salt is a solid, and that is dissolved in what? Water, and that's a solution. Likewise, NaOH solution, solid liquid is a pure compound. NaOH in laboratory, whatever you find solution, it is not the pure compound. HCl, it is a solution, it is not the pure HCl. Yes, students, are you following what I am saying? So NaOH is solid, but about solid also you should know its property. Interestingly, this solid is hygroscopic. Hygroscopic means it traps moisture, it catches moisture, and because of moisture, it doesn't remain pure. Moisture is a foreign compound, no? Moisture means what? Will anybody answer? What is the formula of moisture? What is the formula of water vapor? This is surprising. What is the formula of water vapor? chemical formula of water vapor. Okay, what is the formula of ice? What is the chemical formula of ice? Yes, Ganesh, Ismail, right. Ice has formula H2O. What is the formula of water that we use for drinking purpose or domestic purpose? That we say liquid water. Formula is H2O. What is the formula of water vapor? Yes, it is also H2O. Chemically, it is a water only. Vapor also is water, ice also is a water, and our generally we say liquid, that also is water. The form, solid, liquid, and gases, these are the forms. But chemistry point of view, the physical forms, physical conversion, ice to liquid, solid to liquid, liquid to gas, means water, generally we say, to vapor, water vapor, liquid water to vapor water, gaseous water. In air, in atmosphere, there remains a humidity. Humidity is due to what? Humidity is due to what? Which chemical remains? Which chemical is responsible for humidity? Oh, surprising. You say no, have you heard humidity? Yes, Swapnali, right. It's a water. Humidity means what? Water vapor. When water vapor remains more, now in rainy season, cloudy season, rain falls, no, sir, considerable amount of water remains in the air. So air remains with more humidity. And in summer season, since ocean, sea is near to us, water vapor remains in the atmosphere. But if you go to Kolhapur, at elevated region, then there somewhat dry region, relatively dry region, humidity is less, that we say. Water vapor remains what less. The bikes or any vehicle, if you consider in Konkan belt, it rusts early, but the same vehicle at Vidarbha or Marathwada doesn't rust early. Rusting will be there, but rate of rusting remains more here. It is because of moisture. I am talking about the existence of moisture in the atmosphere. Now that moisture means water vapor. There remains a few compounds. They catch, they absorb the moisture. In kitchen also you will find the salt absorb the moisture. When you pour in the burning, that's a jar. What you will find, it is dry, but after some time it becomes what the sticky. Even for sugar also you may find, or other ingredients also you may find stickiness is because of the catching moisture, so it remains a property. NaOH, sodium hydroxide, is like that category compound that absorbs moisture. And moisture means what? Which chemical? Moisture means which chemical?
H2O.
Yes, it's a water, it's H2O. NaOH has formula, I said now, sodium hydroxide, NaOH is a formula. In that H2 is there. So can we say that hygroscopic, that moisture catched, somewhat sticky NaOH is pure NaOH? We can't say. And we don't know exactly how many water is absorbed. So exact composition we don't know. Then if we weigh that, it will not be the exact weight. Weight can be exact, 1 gram, 4 gram, whatever you want, that you can weigh, sodium hydroxide. But it itself is not pure. If itself is not pure, so exact weight, chemistry point of view, you can't take. So even though you can prepare the solution, that solution you cannot consider as standard solution. Standard solution means from which others can be reported. Its concentration is not changeable. It is exact. Exactly, this is the concentration. After dilution, concentration doesn't changes. But originally, whatever the NaOH, how much taken, that we don't know. Therefore, exact point on normal or desired concentration directly is not possible to prepare. Students, I had given you two examples. One example is of HCl and second one is of NaOH. In case of HCl, it is concentrated acid. That concentrated acid means exact how much gases pass in that solution we can't know. We can't say. One time when manufacturing done, at that time we might be knowing how much quantity of gas is dissolved. But during transport, or if you open that lid, then gas goes out. So quantity will decrease. Exactly how much decrease, that we do not know. So exact concentration of original concentrated acid we do not know. Then after dilution, we can't exactly find simply the concentration. We can't say it is exactly of this concentration. We can say approximately 0.1 normal or 1 normal or zero point 0.2 normal. It is in case of HCl. But what happened for NaOH? NaOH is solid, but its nature is hygroscopic. It catches moisture, it traps moisture, and it itself becomes sticky. It doesn't remain for longer time NaOH, pure NaOH. If compound is not pure, we can't weigh perfectly. If we can't weigh perfectly, we can't prepare its perfect solution. How far the dilution we did. Don't think about balance error. It is because of compound error. NaOH exact weighing that I am talking about. You will weigh 1 gram and you will say NaOH, but NaOH is not pure, no? So pure NaOH 1 gram we can't weigh exactly. So exact solution we can't prepare. Exact concentration we can't say. Therefore, we can't say it is a standard solution. So students, I told you about the HCl solution and NaOH solution. Those cannot be standards. But we want their concentration because for many titrations, acid-base titrations especially, we use HCl and NaOH. So is it possible that we can determine their concentration? For example, in our regular bazaar on Wednesday, Kudal bazaar remains. So if you want to purchase a vegetables, you might have seen even at your rural place also, when vegetables come to your place or while selling also, you might experience every seller, vegetable seller, doesn't remain with all weights. They can be with 1 kg, they can be with half kg, but they don't with, they're with quarter kg, means 250 gram. 250 gram exact weight they don't remain with. So do you know what they do for 250 gram or any weight if they don't have? What they do? Are you getting my question? Yes, Ismail is getting my question. What about others? Are you getting my question? No.
Yes, sir. They weighed whatever which they have in their in.
Yes, they may,
Yes,
sometimes they take
by
tables also.
yes, according to their hello.
Yes, students, that's electricity failure, power failure, and because of that, I lost the network also, and due to which, in between the call break. So I was asking you a regular situation. You might have seen that in bazaar, especially while selling vegetables, then that person doesn't remain with all kinds of weight. But if they don't have the weight, then as Ismail is saying, what they do, they prepare their weight because they don't have ISO mark or standard mark weight, but they prepare their weight. How do they prepare their weight? Somebody might be with that 250 gram weight. They keep that 250 gram in one pan and they add pebbles. One cloth remain, in that they add the pebbles or anything easily available for them, and they make it 250 gram. So what they did, they prepared their 250 gram weight. So if Ismail is a seller and Ismail has prepared that 250 gram weight, then will anybody accept that in bazaar? That they accept, generally we consider that. But as a chemistry point of view, as an industry aspect point of view, as a perfectness point of view, should we accept that? We will not accept that. What we will see, we have to standardize it. We have to verify it. If you verify, then you will accept that. Ismail has done that test already. So for him, it is a verification. So if you have doubt, then you can what? Verify that. So how will you verify? You will compare. Compare with whom? You will compare with standard. So always there remain a standard. And from standard, we can prepare the other auxiliary or secondary standard that we have prepared. That Ismail has prepared, that the new standard weight. That is not primary standard. That is not originally standard. Yes, students, are you getting this point? What I'm saying? Yes, Miss for Ismail, if he takes 10 pebbles or 10 stones, that it comes to 50 gram. It doesn't mean for other students, say for Ganesh, the only 10, he may have to take 11, or he may have to take a 9 stones or pebbles. Then that weight can be 250 because size and weight of the pebbles available at Ganesh, available at Ismail will be what different. Likewise, NaOH in our laboratory, Kudar College laboratory, and NaOH at one of the, say, Sophia College in Mumbai. So that laboratory, that NaOH, what's the duration? That if laboratory changes, then also if company changes, brand changes, if exposure to the chemical changes, the its originality will change, its purity will change. Not necessarily it can be what the same. So what we say, it is approximately, roughly. So HCl and NaOH we can't consider as primary standard. We have to calibrate them. Calibration is not a proper word. We have to standardize them. Now the word you might be knowing, standardization of NaOH. If you remember at FY, that experiment was there for you. Yes, do you remember standardization of NaOH? Have you heard this word? Yes. That standardization you are doing means it is not standard. Then for standardization, what you do? You titrate it with acid. Who? That's Na, which is a base, no? It's alkali. So alkali can be titrated, can be estimated by means of the reaction with opposite reagent. That's acid. So if you titrate it with it, if we titrate it with acid, we can get its concentration. N1V1 is equal to N2V2, or C1V1 is equal to C2V2. That formula in general way it is there, no? We follow the normality aspects, or few where only molarity aspects are what followed. So concentration, exact determination is one of the important tasks, and for that we follow standardization. Can anybody answer to standardize that NaOH? Which chemical you have used? Do you remember? One acid was there. Which acid was there? It was solid. It was white powdered. The name starts with S. It's organic acid.
Sulfuric acid.
Organic acid. Name starts with S. Sulfuric acid is like HCl only. It is not a primary standard. We want such a chemical which is not see, as Ganesh, I want acid. You are saying sodium hydroxide. I want acid. Name starts with S. It's an organic acid. Sodium hydroxide is not organic. It's inorganic base. Second letter of that acid is U. SU. No, Rupashri, it's organic. Third letter is C. Great. Ali at last has answered. Succinic acid. What Ismail was saying, sulfuric, it is not organic. Somewhere sulfur answer came, it was also not organic. One where NaOH is not acid, it is a base. So succinic acid, which is not hygroscopic, pure succinic acid is possible. It may be available. And therefore you were weighing pure succinic acid. You might be knowing its weight also, 0.590 gram. That succinic acid you were weighing. Few where benzoic acid is taken for weighing purpose, for standard solution. So by molecular weight concept, by equivalent weight concept, you will prepare its normal or molar solution. That is a standard solution. That is a perfect solution. That is an exact solution. Why can I say that solution is an exact solution? Because the succinic acid that you are weighing is exactly weighable. It is purely available. It is not deteriorating. You can weigh it perfectly. Pure succinic acid you can weigh. Because of its purity, we can prepare its perfect solution. We can prepare the exact concentrated solution. And from that exact concentrated solution, it's also very interesting. Once one solution is of exact concentration, say succinic acid, then we can titrate succinic acid with NaOH. And by titration, I said no, N1V1 is equal to N2V2. What can we find? We can find the concentration of other reagent, concentration of NaOH solution. Now its concentration will be exact after titration and calculation. That process of finding, that process of determining, that process of calculating exact concentration of unknown solution, that NaOH solution exact concentration, roughly we were knowing it is 0.1 normal or 0.1 molar. But now after titration, we can come to know what is its exact concentration. So that concentration or the process of finding that exact concentration is called as what we are doing from one standard. Yes, Swapnali, absolutely right. From one standard, we are preparing other standard. As like Ismail, what he did, he has taken a standard weight to 50 gram, and whatever the pebbles or stones were available with his weight comparison with respect. So that process is called standardization. So standardization of chemical is necessary. Standard of chemical is necessary to know. Therefore, the basic thing only for which I spent more time, because I found horrible mistakes are there in the basic understanding, fundamental aspects. Clarity is not there, and I felt that somewhere clarity should be there. How is NaOH? How we prepare NaOH solution? Why is not NaOH standard solution? Since it is not standard, we have to standardize it, and that to follow the process of standardization, we need other reagent, opposite reagent of exact concentration, and it should be acid. And that reagent is what? Succinic acid. That you have answered. So we will prepare succinic acid solution, perfect succinic solution by weighing. Then with the help of that, we will obtain the concentration of NaOH. Then that concentration will be correct concentration, or that process is standardization process. Students, is it clear to you? Good. Now I am asking the question to you. In your laboratory, you have prepared succinic acid, and with succinic acid, you have estimated concentration of NaOH. That one step you have done. You have standardized that NaOH. Now you are with HCl solution. HCl solution. How can you standardize that HCl solution? With whom will you react? Are you getting my question? See, you are with three chemicals. One is succinic acid, exact concentration known. Second is NaOH. If you perform titration, you will find its concentration. So now three solutions, out of that two solutions, concentration is known to you. How can you find concentration of HCl? Are you answering in the chat box? Right, Alia, titrate with base. S is acid, so titrate it with base. So titrate it with NaOH. NaOH concentration is known to you. Therefore, so is it clear? I repeat, it's HCl, NaOH, and salicylic acid, three chemicals you are with. Succinic acid, HCl, NaOH, and succinic acid. So succinic acid, exact solution you can prepare by weighing. With succinic acid, you will titrate NaOH and you will find concentration of NaOH. Now, as Alia said now, if you want to find concentration of HCl, titrate HCl with NaOH. So we can get the concentration of HCl. Is it clear to all? Okay. Suppose I am not with that standardized NaOH solution. I am not with succinic acid solution. I am with HCl and I am in need of one more solution. So which solution, exact solution of base that I can prepare? To standardize base, to standardize NaOH, we have prepared standard acid solution. That's a succinic acid solution. To prepare exact concentrated base solution, which chemical shall I use? Okay, I give the hint to you. It is basic salt. It is basic salt, and name starts with first letter of that salt is sodium.
Sodium hydroxide.
No, sodium hydroxide is not a standard. We want standard base. It's a basic, right? But it is not the standard basic, because exact concentration. Yes, Rupasri, you are nearly right. You are near. You are right. But improve the answer, because that sodium bicarbonate is a weak acid, weakly acidic. We want it will be strongly acidic solution. Improve your answer. The name starts with sodium. Oh, mistake is there, Rupasri, in representation. In formula writing, mistake is there. Can anybody improve? You can write formula or you can write its name. Okay, Alia has improved the formula. What is its name?
Sodium chloride.
No, sodium chloride is neutral. I want basic. Basic answer is given.
Sodium
Rupasri is given.
bicarbonate.
Alia is given. Sodium bicarbonate is NaHCO3. NaHCO3 means sodium bicarbonate, Rupasri. Na2CO3 means, yes, Ali has given the answer. sodium carbonate. So, and sodium carbonate is washing soda. So with the help of the sodium carbonate, we can prepare standard basic solution. And that sodium carbonate we can titrate with HCl. And after the knowing the endpoint, we can find out the concentration of HCl. So these are the ways by which we can find the solution of other. We can prepare the other milestone. We can prepare the other standard from one standard to other standard. But primarily, basically, there should be some standard. So what is that concept? Standard or standardization, standard chemicals. There's a different reagents. So that we need to discuss. But only what I did today, I did the basic concepts clear. So whatever today's discussion is there, from understanding point of view, from little practical approach point of view is important. But from book syllabus point of view, whatever I could not discuss more, only I went to discuss the basic concepts. That's the acid, base, primary standard, secondary standard. That only I went on discussing. Actually, you are supposed to know those things. Doesn't matter. I will teach you the additional portion next time. But what I discussed today, I want notes of that. You can write down that now, what I discussed. I ask you about standard solution, means exact concentration, means NaOH. NaOH in original form, how it remains, liquid or solid. That answer you have to write in assignment. Means as a summary of today's notes. HCl, constant HCl solution, pure HCl is a solid, liquid or gas. That you have to answer. The second point you have to cover. Now concentrated HCl, what is its exact concentration? Generally, industry manufacturing remains no approximately. I said 10 is a very rough. Other number also I had given to you. What is that concentration of HCl? And can it be primary standard? Can we prepare exact solution of HCl? Then answer is no. That you have to write down. Similarly, come to NaOH. NaOH pure form remains solid form. Is exact weighing possible? Answer is no. Write reason for that. Then write how to find exact concentration of NaOH. Then you will say that you will prepare succinic acid solution, standard succinic acid solution, and you will titrate it with NaOH using say phenolphthalein indicator. And then by calculation, you will find concentration of NaOH. What's the name of that process? You have answered rightly, standardization. That you will write down. If acid remains, how can you standardize? That different ways you can write down. One way, if NaOH is standardized, titrate NaOH with HCl, you can standardize the HCl. If there is no NaOH, there is no salicylic acid or succinic acid standardized, then what can you do? Which chemical? Yes, sodium carbonate. That sodium carbonate with which you can standardize. Its molecular weight, purity remains. So what is expected from the standard? That conclusion I write down. Its exact weight can be determined. Is exactly weighable. It should be pure. It should not be hygroscopic. So such qualities you have to just mention. Students, is it clear what I asked today? Yes, by evening I will load this lecture. I will upload this lecture. So there you can if you have doubts, you can go through it. But basic concepts only. You have to prepare summary of this lecture from practical. Any doubts are there, you can ask. Yes. Yes. Do you have any doubt about the concepts that I taught, that I discussed? Okay, then the remaining portion I am discussing tomorrow. Means actual syllabus. So tomorrow at morning 9 o'clock. Okay, will it do? Please reply. Yes. Anybody said no? All are saying yes. Okay, good. Okay, I am stopping the recording and I declare now today's session is over.